In this video we'll go over the solution of January 2011 question 1 from the Edx M3 paper. Here's the question. So it's a question on variable acceleration, and in this question the acceleration is a function of x, a function of displacement. So pause the video and read the question carefully. Right, we're given that the acceleration is 7 minus 2x measured in the positive x direction. So we can write down an expression for acceleration. And normally we write acceleration as dv by dt. But in this sort of question, that's not much help because you can't integrate that directly because you've got dv by dt as a function of x. So the trick with these questions is to write dv by dt as, well, this is how it works. Use the chain rule, and then you'll see that that is v dv by dx, because dx by dt is velocity. So, writing that in there then, we've got something that we can integrate, because that's a differential equation that's separable. Like that. If you haven't done that yet in pure maths, you'll be doing it soon. There's some extra notes on the integral maths side to explain the technique. It's called separating the variables. We now integrate both sides and get v squared over 2 equals 7x minus x squared plus c. Now we look back in the question and look for the initial conditions. When t is 0, x is 0, and v is 6. That's the important bit. X is 0 and v is 6. Therefore, putting that in, we'll get that c is 18. So v squared, doubling everything, is 14x minus 2x squared plus 36. Right, that's finding v. We need to know v because the question finally asks us, although it doesn't specifically say find v, we have to know it because we've got to find the value of x, the distance from O, when p comes to instantaneous rest. In other words, when v is 0. So let's just go to the next page and carry on with the question. What we've just found is that we've got v squared is 14x minus 2x squared plus 36. And we're going to put that equal to 0. So, just rewriting it and simplifying it. And then finally factorizing. So, the two possible values of x are x is minus 2 or x is 9. And since it was going in the positive x direction with speed 6, and the acceleration over this first period, the acceleration is positive, the one we want is x is 9. It can't be x is minus 2. So, therefore x equals 9. Okay, let's look at the mark scheme for that. There was a M1 mark for writing v dv by dx, and then a method and 2 accuracy marks for doing the integration and finding the c. Well, 1 method mark for this, and a total of, that's right, 2 accuracy marks. Yep. And then for the second part, we had just an M1 for putting it equal to 0 and doing the factorizing, and an A1 for getting the final answer. Okay, that's it. Thank you for listening.